In numbers 23 through 26, we're asked to find domain and range and to identify if the relation given is a function. The domain is the set of all x values, and we see ordered pairs. There are 4 points there, so there are likely 4 x values. I'm going to list them in increasing order from least to greatest. So I'm going to start with 0, 1, 3, and 4. Those are the x values. They are included in braces to indicate that we have a set, just like the ordered pairs are in set notation. The range is the set of all y values, and so I'll circle the y values in each of the ordered pairs. I'm also going to list those in order from least to greatest. -2 actually is not the smallest one. -7 is the smallest, followed by -2. Followed by +9. I'm not going to list -2 twice because it is just one element. So there are 4 elements in that set. And now we need to determine if the relation is a function. The relation is a function if each x corresponds to only one y. So 3 corresponds to -2, 4 corresponds to 9, 0 corresponds to -2, and 1 corresponds to -7. Each x corresponds to only one y. So this is a function. Another way to look at it, if x values are repeated, then we have a relation that is not a function if you're looking at a set of ordered pairs. For number 24, this is the same sort of a question, but now we have the ordered pairs in graph form. If you want, you can write the ordered pairs in next to each point. So this first ordered pair is -4, 5, and we have another one, -2, 2, and this one is 0, 1. This one is 3, 2. We have another down here, 3, -1, and another 5, -3. When you're writing ordered pairs, be sure to use parentheses. The domain is the set of all x values. So let's circle our x values. And I'm just going to list those from least to greatest, which on the graph is from left to right. So -4, -2, 0, 3, and 5. Even though there are 1, 2, 3, 4, 5, 6 points, there are only 5 elements in the domain because 3 is an x value that is repeated. The range is the set of all y values, which if I'm listing them from least to greatest, we'll start at the bottom. So at the bottom, the smallest y value is -3. Next largest is -1, followed by 1, followed by 2, and followed by 5. There are only 5 of those as well because 2 is repeated. This relation is not a function, and the reason it is not a function is because +3, x equals 3, maps to 2 separate y values. For number 25, this is different from the first 2 questions because now we have a continuous graph, which means it not only includes whole numbers or integers, but all the numbers that fall in between as well. So we'll need an inequality to name the domain. The smallest x value is -5, and the boundary for the largest x value is +4. So our domain is x is between -5 and +4. Remember to point those inequalities toward the smaller end, and we'll put inclusive on the -5. Now to find the range. The range is a set of all y values. So I'll start here with our smallest y value, which is -2, and the boundary for the largest y value, which is right here at the top, is +1. So our y values are falling in between -2 and +1. Make sure that you're using the variable y in this inequality. And -2, the y value is included because that bottom point on the graph is filled in. The top is a hole or an open circle. This relation is a function, And you can test it using the vertical line test. Any vertical line intersects the graph no more than one time. For number 26, this is similar. So we're going to look at the domain, and as we travel from left to right, I notice the left side has an arrow on it, and the right side also has an arrow on it, which means the graph continues all the way to the left and all the way to the right. That means our domain is all real numbers. You can use the symbol or you can use the words all real numbers there. The range is the set of all y values, and there is a lowest y value, and that lowest y value is -2. So that means that our range is y is greater than or equal to -2 because all of the y values on this graph are above -2 or at -2. This relation is also a function because any vertical line intersects the graph no more than one time.